Hello and a warm welcome to this webinar, How to Save Time and Cost when Migrating to CE 2.0 Grade Services from Verax Technologies. My name is Manikantan Srinivasan, the moderator for today's session. I'm currently a technical advisor at Verax, and my previous engagements include various technology developments at Verax and at Arecent. Let me give you an overview of this webinar. As the communication networks are continuing to evolve, the service providers, you must differentiate yourself from your competition by providing a rapid design and deploying newer services, suitable EPL service or an AVPL service or ELAN, AVP-LAN, E3 to your customers located across the globe. So when you are designing and deploying these services, ensuring that the service is of complete integrity and they are really up to the mark before you turn up, and ensuring that the network downtime is minimum is very critical. You would agree with me in this process that reliability, efficiency, and cost effectiveness is very crucial for the organization such as yours. So as the demand for this Ethernet business services and Ethernet backhaul is on the high, it's very imperative as service providers that you need to employ strategies for migrating to carrier Ethernet 2.0 grid services using standardized approaches. In this webinar, Verax will be first presenting the various challenges that are typically faced by service providers and carriers in designing and deploying the carrier Ethernet 2.0 services. Once we share the challenges and overview of Verax solutions that would help service providers to improve with efficiency by which they can offer CE 2.0 services to the customers will be demonstrated. In this webinar, we have two poll questions during the course of the session, and in the end, we would be handling the question and answers. So please feel free to provide your questions during the course of time in the question box. I do understand that many of you have joined are in various different roles, very senior roles in your organizations, such as your architect, are your service assurance engineers, network technicians, product managers. I once again thank you for taking your time and joining this webinar from Verax Technologies, and I look forward this webinar will be very informative to you. In this webinar, I now introduce you the two speakers for the webinar. Madan Panchaksharam, he handles the product marketing at Verax. He will be providing you a detailed overview of the challenges that are typically faced by service providers when they turn on the services, when they design the services for the customer, whether it's an EPL, EVPL, EVP-LAN, etc., and ensuring that the services are compliant, conformance to the MEF standards, and testing for the service activation and troubleshooting as the services are progressing. The next speaker is Sriram Kalyanasundaram, who is from the Carrier Ethernet Technology Architecture Initiatives at Verax. He will be providing you an overview of the Verax solutions and a demonstration of the Verax products that will help you to turn on the services. Before I hand over the platform to Madan, a very brief introduction of Verax. Verax is a provider of test and measurement solutions for the communication industry. The company was founded in the year 2002, and over the last 11 years, Verax has offered automated test solutions for testing requirements in access, carrier Ethernet, data center, and industrial networks. Many of Verax customers also utilize Verax test expertise for performing test services based on Verax and third-party testing products utilizing the ready library from the Verax test portfolio. Verax is a leading provider of conformance test solutions for various standards. Now, for the quick poll, first poll for the webinar, please provide your input to this poll question. In this question, we would like to understand what best describes your position with respect to carrier Ethernet service turn-up testing. What you consider, which standard level is sufficient and would help to meet your customer have a good seamless quality of service when the service is turned on. We'll wait for 30 seconds. That would help you to provide this input for this poll, and once it's done, I would be handing it over to Madan. So please share your thoughts on this poll question. Thank you very much for sharing your thoughts on this. Now I hand over the platform to Madan, who would share the challenges typically faced by service providers in the designing and turning up carrier Ethernet services. Over to you, Madan.
Thank you, Mani. We'll now understand few challenges faced by carriers in each of the following phases. Firstly, designing the new CE 2.0 grade services, verifying conformance of the new service with respect to CE 2.0 specifications and having them MEF CE 2.0 certified, ensuring complete integrity of the circuit before service turn-up, and finally troubleshooting. Designing a new CE 2.0 grade service has the following considerations for network architects. The first step, of course, is choosing the right kind of network equipment for each of the network nodes. In this process, more often than not, you end up selecting equipment from different vendors for each of the nodes based on your requirement. So it becomes very important to verify the interoperability of these equipment to deliver a seamless experience to the customer. Next, one needs to benchmark each equipment and each portion of the circuit to ensure that how many simultaneous services of a specific product type that each of these equipment or circuit portions can simultaneously support. For example, how many 30 Mbps bronze services the equipment or a network portion can support simultaneously. You would like to verify whether your existing carrier Ethernet network equipment, which is MEF 9 and MEF 14 certified, is ready to scale up to CE 2.0 before considering any new investments on CE 2.0 certified equipment. Hence, you would typically want a standard test platform to benchmark the equipment that you already have against the CE 2.0 requirements. In this process, one would also like to benchmark the performance of the circuit for various traffic conditions, such as varying packet sizes, information rates, and varying burst sizes. Also, you would like to optimize the equipment configurations across nodes to maximize the utilization of the equipment to deliver best possible performance SLAs. One also needs to be able to do a lot of plug and play of equipment from different vendors while designing the service, trying to compare their functionalities and the maximum SLAs that are being achieved in each of these vendor equipments. In summary, there is a lot of effort in planning, evaluating, and designing the new services. After such a detailed design analysis is done in the lab, if you deploy the network, you'll have a complete understanding of the capability of each network node and the circuit. Moving on to the next slide. Now, getting more specifically into the MEF conformance from a carrier's perspective, preparation for MEF CE 2.0 conformance starts with understanding the specifications. MEF CE 2.0 is much advanced compared to MEF CE 1.0 in many aspects, such as the new service types like EVP LAN, EP tree, EVP tree, Access EPL, and Access EVPL services that are being defined. Also, there are new concepts such as multiple class of service, color modes, performance parameter measurement methodologies, burst handling requirements, and control frame handling requirements. Control frame handling is applicable to packets such as L2CPs and service OEM frames. Understanding these new concepts is more effective hands-on than just the literature review. You would like to play around with various configurations for each of such requirements and see the end realization of the functionalities. More interesting aspect would be to understand how these functions work together to deliver a seamless end-user experience. It would be necessary for carriers to understand and actually benchmark these aspects before presenting their services for MEF certification. Testing in preparation for MEF conformance could be an enormously time-consuming activity when done manually. It would involve testing for numerous CE VLANs and cost labels for specific service VLANs, testing the behavior of L2CP and service OEM frames, and also ensuring that cross VLAN traffic delivery doesn't occur for any of the VLANs. Also, this would require creating multiple different traffic streams for each of these packets, capturing them at the other end, and manually analyzing each of these streams for integrity. All these verifications, if performed manually, would consume significant amount of time. Moving on to the next slide. Once carriers are certified for MEF CE 2.0 and they start selling the services, next phase will be performing service activation tests before actually turning up the services to the customers. Today, most service providers are typically performing RFC 2544 or 1564 verification as part of their service activation testing. However, like the proverbial tip of the iceberg, experience shows that there are a number of other problems that could potentially lie undetected until the customers start using the network. And it would therefore be desirable to determine and remove these potential hidden problems. This becomes all the more critical when you are offering services through multiple partners. For instance, many of you must have observed that the common cause of most customer reported issues point to configuration mismatches resulting in issues relating to VLAN preservation, cost label preservation, burst handling, port security, and control frame handling. This is because RFC 2544 or Y.1564 standards are primarily focused on the performance parameter verifications. However, they do not ensure many of the functional aspects that we'll discuss now. Firstly, VLAN preservation. Let us now quickly see how is the VLAN preservation issue prone to happen? If you see this example, VLAN 10 is the customer VLAN that needs to be preserved end to end, that is between UNI and the UNI. But as you can see, the service involves multiple operators. Each operator's network will be subject to handling overlapping VLANs. Hence, the carrier switches are generally configured to stack its own VLAN on top of the customer VLAN. This is done to ensure the traffic separation between customers. So this means that there are multiple configurations across various equipment involved in the end-to-end delivery of the traffic. Also, it involves different set of configurations for upstream and downstream traffic. So if any of these configurations go wrong, then the VLAN will not be preserved. If VLAN is not preserved, then the customer CPE will not accept the frames. Therefore, you can now clearly see that VLAN configuration mismatches can potentially result in erratic loss of traffic for customer, security threat, and potential bandwidth degradation for other customers. Though your initial Y.1564 verification might have passed, testing for VLAN preservation can indicate that the cross VLAN traffic has actually contributed to the 1564 results. So similarly, the cost configuration mismatches can result in potential degradation of service SLAs for the customer, potential SLA misbehavior. For example, voice can get less bandwidth compared to data if cost configuration does not match. Next is port security. Carriers need to ensure the number of MAC addresses allowed on a particular customer port is restricted. If this is not done, the port can learn more MAC addresses on a network equipment and thereby exhausting the MAC table. This could result in potential performance degradation for other customers whose MAC addresses will be restricted from being learned on the equipment. Next, we have bandwidth profile related issues. Carriers often resort to over-provisioning of their circuits to allow more than the agreed CIR, which is committed information rate, or CBS, which is committed burst size, to avoid issues after service turn-up. While this might be beneficial to the customer, it results in underutilizing of the network equipment. For example, over-provisioning might restrict an equipment which could have supported 100 services to support only 80 services. Next, we have frame handling related issues. For seamless delivery of the service, it is important to ensure the control packets such as L2CPs or the service OEM frames are appropriately handled. For example, the improper handling of a service OEM frame can result in false alarms raised by fault management systems. To give a specific scenario, suppose if the service is configured to tunnel service OEM frames, but in reality if the circuit doesn't tunnel the service OEM frames, then the subscriber MEP, which is monitoring the service, would detect a fault and raise alarms. However, this is a false alarm that is being raised, even when there is no fault in the service. This could result in unnecessary effort towards troubleshooting the cause. And finally, when it comes to troubleshooting, it could be a time-consuming activity in isolating CVLAN or cause that is not preserved end-to-end, or the MAC address that is not being handled properly. Even though the initial configuration would have verified all these aspects during service turn-up, there are chances that these configurations get overwritten during subsequent service configurations. So a quick verification of these aspects should be possible to ensure that you reduce the network downtime. Often during troubleshooting, you would want to quickly verify whether VLAN traffics are crossing each other. This is done to ensure that you're troubleshooting for the right traffic. Also, in case of performance issues, specifically relating to burst, it could be a challenging task to isolate the exact burst sequence or timing which is creating an issue. You would require a standard aligned tool in order to accurately compare the behavior against a standard benchmark whenever customer reports such an issue. And most importantly, performing such troubleshooting by deploying field technicians could be significantly time consuming. So there needs to be a way to perform such troubleshooting from a centralized location. So briefly, I've covered many of the challenges that service providers face today in migrating to Carrier Ethernet 2.0. That overcoming these challenges could be significantly time consuming and thereby escalating the operational costs. I now pass it back to Mani to take the discussion forward.
Hi, Madan. Thank you very much for highlighting the various challenges that the service provider and operator would face when they do a design of the service for their customer and then do a testing when they are activating the service, and also for them to ensure that the service is completely on time always for them. The picture that you have represented like an iceberg where typically people look at some points but probably could not look at other service VLAN, CAS, and port security, which are very critical for a Carrier Ethernet service. I think it's very well the service provider should know and should have a standardized procedure, not only just at the turn up, but also have a centralized way, and it will help them. It's a very good one. And before we move on to providing a demo of the solution, it's a quick poll, and I request the audience to share what they think is best suited for the Carrier Ethernet service turn-up testing. Just 30 seconds of your time. Please share your thought as what would be best suited. Is it just based on the NID capabilities, or a combination of a NID and test probe with additional features, also a solution which can provide sufficient reports, or what would help? Thank you for sharing your thoughts on the best suited for the Ethernet service turn-up testing. Now I would request Sriram to share the attest solutions that would help the service provider for them to do the service turn-on test and the other tests.
Thanks, Mani. Now we shall cover how Verax solution can help overcome the challenges discussed so far. There are two solutions that Verax provides. Verax SamTest solution is designed to help carriers in verifying device interoperability, benchmarking the equipment and circuit for performance and scalability, performing quick and comprehensive service activation tests before service turn-up, and quickly troubleshooting to reduce the network downtime. Whereas Verax Attest solution is designed to test for MEF CE 2.0 conformance towards preparation for MEF CE 2.0 certification by MEF authorized test agency. Moving on to next slide. Now I'll explain the highlights of SamTest and go on to a live demonstration. As I said, Verax SamTest can be used in the lab environment during service design and also in the field during service turnup and troubleshooting. SamTest pre-built tests cover MEF CE 2.0 tests tuned to meet service activation testing and Y.1564 verification. The platform is flexible for customization of existing tests and addition of new tests. In the field environment, SamTest has a centralized controller that connects with Verax test probes, executes the test, and captures the results. The tests are performed either using data or service OEM loopback messages. SamTest comes in two different variants. Variant 1, where testing can be performed using test probes at both the ends. It can be between uni and a uni or uni and a ANNI. In the case of a Ethernet wholesale, where the service provider do not get access to access provider network equipment, many service providers use this variant. Also, the test coverage is more comprehensive to include all of the CE 2.2 requirements as part of service turnup. This is because typically in case of wholesale, you'd want to ensure maximum integrity before turnup. Otherwise, troubleshooting a live circuit involving multiple operators could be significantly time consuming. Variant 2 can perform testing using test probes at a suitable aggregation point and looping back the traffic from third-party Ethernet access devices. Typically, this is used in cases where service providers want to optimize the time taken to ship the test probes to the access network. Moving on to next slide. The chart you see on the screen lists the matrix of test coverage across the variants. The differences lie mainly in performance measurements. Using test probes on both ends, one can perform one-way measurements. However, in the niche scenario, the performance values are derived from two-way measurements. Other differences are with respect to CBS enforcements and verifications for untagged and priority tagged frames. Moving on to next slide. SamTest also be used in lab environment where the endpoints of the circuit can be connected to the Verax test probe. SamTest controller in turn connects to the test probes and initiates the test. The tests are performed using data frames in the lab environment. Now we'll give you a brief demonstration of Verax SamTest. I hope you can see the SamTest screen. Tests in SamTest can be viewed by clicking on the Profiles button. The test library you see on the screen is classified based on service type and the test method. We have three types. The first one, CU 2.0 functionality test using data frames. CU 2.0 functionality test using service OEM loopback frames. And finally, the Y1564 test. These three types are applicable each of the service types. For example, you see on the screen library for EAS and library for E-line. The user can also create custom profiles based on the pre-built test. Each library has pre-built test profiles. The tests are further classified into activation tests and diagnostic tests. The activation test covers CE 2.0 attribute verification and performance tests. As you can see on the screen, each of the functionality tests such as VLAN preservation, cost preservation, MTU, MAC and port security, information rate and burst size tests are grouped appropriately. SamTest tests are automated, so they save a lot of time and effort in running the test, especially when they have to be repeated. Although they are automated, users have a great level of control in performing the test. Often tests that takes days or weeks can be completed in a few hours. That is a huge saving. The workflow in SamTest starts with creating a database of products offered by the service provider. When customer orders a service, the details about the customers must be keyed in under customers. Then the customer can be associated with a product by creating a circuit and specifying the circuit detail such as SVLAN and CVLAN. Before starting the test execution, the details of the test probes or NIDs must be configured in the controller. This can be done by clicking the probes button or the NIDs button under the assets and specifying the details. Once the test probes or NIDs are configured, tests can be started by clicking the execute and selecting the circuit to be tested. You must specify the probe ports that you want to use for testing. And select an existing test profile and specify the test duration parameters. The user can modify the test profile or create a new test profile before initiating the test. During the test execution, you can use the live chart utility to monitor the traffic rate and frame delay variation. The green line in the chart indicates the transmit rate and the red represents the receive rate. To move on to how SamTest aids in failure analysis, let us take a look at a failed log. In case of a failure, the test log provides information about failure cause step by step. In this example of a CVLAN preservation test failure, the log shows the comparison between the expected frame content and the received frame content. It also provides an illustration by providing the frame difference. The one on the left is the expected frame content and the one on the right is the received frame content. And the difference is clearly highlighted by means of a red band. Similarly, each test log provides appropriate information to aid easy analysis. So the user knows what the issue is and can zero down very quickly. A failed test would also point to the relevant diagnostic test to be performed for further analysis. In case of a bandwidth profile test failure, the log that you are looking currently on your screen shows a mismatch in the expected versus received frame count. SamTest displays a detailed report of the circuit in a birth certificate format, which can be exported to PDF and published to the customer and other stakeholders. The report also shows the values of performance parameters along with graphical charts for easy comprehension of results. So that was the brief on the SamTest and the SamTest demonstration. We'll now move on to a brief overview of ATTEST followed by ATTEST demo. Verax ATTEST solution is designed for MEF CE 2.0 conformance and maps one-on-one to the MEF CE 2.0 test plan. So carriers can be certain that they are meeting MEF conformance requirements. Verax ATTEST solution is also valuable for ongoing tests that need to be performed from time to time to ensure that the services are conforming to CE 2.0 when you change or add more network elements. Similar to SamTest, ATTEST can also be used in both lab and field environment. ATTEST tests map directly to MEF CE 2.0 test plan, and all the tests can be executed in an automated fashion. Now let's move on to ATTEST demo. The GUI you see on the screen is the ATTEST user interface. Test cases can be accessed from the test case manager. The test suites available are listed in the catalog pane. There is a test suite for e-access, e-LAN, e-line, and e-tree service type. Expanding the tree structure provides you or displays the groups and subgroups followed by the test cases. Selecting a test will display the information about the test, such as the test objective or test purpose, reference in the standard or specification, test topology, configuration, and the test procedure. ATTEST also provides you with reports for the tests that are executed. These reports can be viewed from Test Progress Manager. The report gives you a summary of the tests that passed, failed, and inconclusive. These reports can be exported as PDF, and CSV. Further information about a specific test behavior can be obtained from the test log. There is also a packet sequence display which displays the packets exchanged between the test probe and the device or circuit under test. So that ends the brief demo on our test. Back to you, Mani.
Thank you, Sriram, and it was a very interesting demo, and being able to clearly highlight how Verax is offering its solutions. One, to check that the service is conformance to the MEF CE 2.0 service, and also how one could do a service turn-up test and also can do a periodic troubleshooting or a periodic maintenance check by storing the configuration and loading it. The many benefits that you highlighted are like very detailed test logs with the level of mismatches, and I'm sure that it will help one to quickly narrow down and save time when they are providing their maintenance. So now let's move on to a set of question answers that we had seen during this webinar. We have received a few questions during this webinar from our audience, and let's handle first a few of the top questions. And if we miss out any response to your questions, we will be answering them in an email following up our webinar. First question that I see is, many NID vendors already provide capabilities for service activation testing. So in that regard, what is the key differentiator for the Attest product for the service activation test?
Hi, this is Madan here. I'll take that question, Mani. I think this is a very important question. NIDs cover mainly Y.1564 or RFC 2544, but Verax SamTest coverage is much beyond that. Also, many of you would want to do an independent validation of your network using third-party tools. There are chances for bias when the service activation testing is also performed using the same equipment vendor solution. And importantly, NIDs can provide measurements but not so much of inputs to help you in troubleshooting. Also, in the case of wholesale Ethernet, the kind of verifications that many of you do today cannot be performed using the NID capabilities. And many of you might be using test probes to do that. Verax test probes go beyond the other available test probes in the market in providing pre-built tests and also enabling you to execute them in an automated fashion. Yeah.
Thank you. Other question that we are seeing here is about the mention of Verax Attest being mapped to MEF CE 2.0 test plan, and it is meant to help prepare for the MEF CE 2.0 conformance. Does it mean for a service provider when they use Attest, when their service passes, that their service passes with the Attest, that they are MEF CE 2.0 certified?
Again, Madan here. I'll take that question, Mani. Today, only a MEF authorized test lab can test and award any service provider a certification for MEF CE 2.0 compliance. Using Verax Attest will help them in the process. So, when you clear the tests with Attest, you can avoid surprises when you present your services to MEF authorized test lab. So this is one application. But there are also applications beyond this. So A service provider might present a specific circuit of a particular product type for certification with MEF. However, they might be creating many such circuit instances over a period of time. In the process, they might be procuring equipments which are enhanced versions of the equipment from the same vendor, or in some cases applying patches to the existing equipments that they already have. In some cases, they may even procure similar equipments from different vendors. In all such cases, they can use attest to ensure that they're still maintaining the MEF C2.0 conformance. Attest being automated, this quick sanity can be quickly done in a span of hours.
Okay, so the basic benefit is a customer or the service provider can repeatedly verify the service by running it whenever there is a change in the circuit.
Yes, exactly.
Okay. Another question that we see is, okay, there is a version of SamTest which is utilizing the features of the NID. So, what are the capabilities that are required in the NID to enable perform the test using the SamTest?
I'll answer that, Mani. This is Sriram here. SamTest would require needs to support the SOAM standard, that is ITUT Y1731, or a loopback with max swap configuration to facilitate our testing. When we use loopback with max swap feature in the NID, the Verax test probes will generate data frames. In this case, the port on the Ethernet access device must be configured to swap the MAC address, that is the source and destination MAC address, and loop back all the received frames. When we say service OEM loopback, Verax test probes will generate service OEM loopback messages to perform the testing and would expect the NID to respond to those messages. In case Y1731 service OEM is to be used, the MEP details MEP needs to be configured on the NID to monitor the circuit. In case of loopback with max swap, since we are using data frames here, we can perform certain additional verifications such as all-to-one bundling, maximum number of CVLANs that are supported, and CBS and EBS enforcements. I hope that answers your question.
Thank you, Sriram. One last question. What are the configurations that a service provider would need to do would need to specify in SamTest before initiating a test on a service that is being activated?
I'll take that to one, Mani. This is Sriram again. We need to mention typical circuit details such as the service VLAN or allowed CVLAN, cost, performance parameters such as CAR, CBS, EAR, and EBS, along with the expected performance SLAs such as frame delay, delay variation, and the frame loss ratio, etc. This again could vary for different service types. For example, EAS could be slightly different, the information you provide, and for ELINE or ELAN, it slightly will be different.
Okay, so the configurations, there are a set of generic configurations, and there are a few specific service-specific configuration that needs to be.
Yes.
Okay, and that was the last question that we had, and this brings to the end of the QA session. And I thank you, Madan and Sriram. And this presentation really highlighted many of the service provider challenges and the kind of a standardized approach that when a service provider follow would help overcome these challenges. I think certainly overcoming many of these issues in the service design and during service turn-up would certainly substantially reduce the operational expenditure and also in maintaining and troubleshooting the networks after they are turned up. And most importantly, that from Verax side we emphasize is an organized approach would help in developing your loyal customer base. So So I take this opportunity to once again thank all the participants who took your time to join us in this webinar. The recording of this webinar will be available shortly, and information regarding this would be sent to you in an email. If you have any questions, any further clarification, please feel free to email to those speakers' email addresses which were shared in the earlier part of the presentation. Thank you once again and have a good day. Bye-bye.